Hey everyone, welcome back to my channel. In today's lesson we are going to talk about super useful concept in programming, the strategy pattern. But don't worry, it sounds more complicated than it is. I will break it down so that you can understand it easily and use it in your Java project. Let's go. So before we dive in the strategy pattern, let's quickly cover what design pattern is. A design pattern is basically a proven solution to a common problem in software design. There are different types of design patterns, and one of them is called behavior design patterns. Now, behavior design patterns are all about how objects in your program interact with each other. Think of it like this. It's not just about the object do, but how they do it and how they communicate. Today we will talk about the strategy pattern, which falls under this category. So in the short, the strategy pattern let you choose different ways to do the same things, like using different strategy for attacking the game. So imagine you decided to create an app for managing online payments. The app is centered around providing users with different payment options to make their transaction quick and easy. Initially, you only allowed users to pay with credit card. This worked great, and people using your app to make purchases with their cards very happy. But soon enough, you started to get requests from users who wanted to pay using different methods. So you add the option to pay with PayPal. After that, you introduce another method, paying through bank transfers. All of a sudden, users were thrilled with the flexibility of your app. But the demand didn't stop there. Soon, more users started asking for options like Apple Pay, Google Pay, and even cryptocurrency payment. As you plan to introduce even more methods like gift cards or in-app credits, things started getting complicated, and the code becomes bloat. So the code bloat. At first, the app was running smoothly with only one credit card payment method. But as soon as you started adding other options, PayPal, bank transfers, and so on, the code for processing payments became bloated. The main class, which handled the payment processing, grew uncontrollable. Each time you added a new payment method, the class doubled in size. From a business perspective, the app was a success, but maintaining the code turned into a nightmare. Each payment method had its own set of rules, validation, logics. When you had to fix a bug or make a change to one of the payment methods, it was easy to accidentally break something in another part of the code. Also, collaboration struggles. The collaboration struggles as your team expanded, the problem got worse. When several developers work on adding new payment options, at the same time they all had to modify the same massive payment class. This led to constant merge conflict and slowed down the developer process. Each new payment method required changes in multiple places, and the team often found themselves stepping on each other's toes. So, what is the solution? The solution is strategy pattern. This is where solution pattern shines. Instead of keeping all the payment methods crammed into the classes, The strategy pattern help you organize them better. You can separate each payment method, credit card, PayPal, bank, transfer, into its own class, each following the same interface. The main class, your payment processor, simply selects the right strategy for payment method based on what the user wants. With this approach, adding new payment method like Apple Pay, Google Pay, or even cryptocurrency becomes super simple and clean. You just create a new strategy for each without touching the existing code, reducing the risk of breaking anything. Plus, your team can work on different strategies at the same time without stepping on each other's work. So, wonderful! This keeps you calm, flexible, maintainable, and ready to adapt to a new payment method in the future. So, let's see. This is actually how it looks like. We have context, we have interface, and we have strategy. When to use it? Use the strategy pattern when you want to use different variants of the algorithm within an object and be able to switch from one algorithm to another during runtime. Use the strategy when you have a lot of similar classes that only differ in the way they execute some behavior. Use the pattern to isolate the business logic of a class from implementation details of algorithms that may not be as important in the context of this logic. Use the pattern when your class has a massive conditional statement that switch between different variants of the same algorithms. So, what is the cons to use pattern? The cons: unnecessary complexity. If you only have a few algorithms that rarely change, using the strategy pattern might make your code more complicated than it needs to be. Client awareness. The client of user must know the difference between strategies to choose the right one. 3. Modern alternatives. In many modern programming languages, you can use anonymous function to implement different algorithms without needing to create extra classes or interfaces, keeping the code simpler. So, what is the pros? You can swap algorithm use inside an object at runtime. You can isolate the implementation details of an algorithm from the code that use it. You can replace inheritance with composition. And also our favorite open-close principle. You can introduce new strategies without having to change the context. So let's see in the code how it looks like. So first of all, let's open our IntelliJ. I have already created class. So let's see. Let's imagine we have some class payment method processor. It's architected. It has a little bit interesting design. We have just one method that return void. So also we have main class where we call this method. So here we see we can actually change it with switch case, but let's use hard. Let's use if else. So when we call process method, we choose if payment type equals credit card, we use process credit card payment. Else, if we use PayPal, we will use method this one. Everything is in one class. It's work perfect, but when let's imagine that we have more and our class grows without end, so it's not good design. Let's imagine we have another option. We have main class. We create a payment class. We organize it. In payment processor class, we passed payment strategy. Payment strategy actually it's interface, and our interface we have just two implementation, but of course we can easily implement it in other implementation. So let's see, we have credit card payment. We implement it and display our process. So let's go to the interface and let's imagine we receive the new task to create new method. For example, I don't know, let's say Google Pay. Okay, very easy. We are doing our geology and create actually our method. This is Google Pay method. Let's do it like this. Now let's run main application. We forgot to call this method new payment processor. New Google Pay. Google Pay processor. Google Pay processor. Let's say like this. Now it's better. Google Pay processor, process pay, and let's put 9. So let's see, we create the method and it actually works perfectly. This is Google Pay method. So thank you for watching. Please use strategy pattern and enjoy.